This is objective number 6 for Unit 5 Earth's History. Notice objective 6 involves Earth Science Reference Tables page 8 and 9 and the vocabulary that is associated with the history of the Earth. You can pause the slide right now and copy down the objective number 6 and put tomorrow's date. On this slide you can see geologic time is subdivided into smaller units. We take all of Earth's history and break it down into eons. Eons are split into eras, eras into periods, and periods into epochs. You do not need to memorize these words because you can see they're on page 8 and 9 of the reference tables. If you look up at the top left, you can see the word eon, and then split into smaller eras, which are split into smaller periods, which are split into smaller epochs. The 3 eons that we will talk about tomorrow are the Phanerozoic, which you can find over here on the left, the Proterozoic, which again you can find over on the left, right, and the Archean, which are under the eons on the left, page 8 of the reference tables. We can take those eons, split them into 4 eras. They are the Precambrian, the Paleozoic, the Mesozoic, and the Cenozoic. So for an example of these eras, watch this little video that gives you an idea of what each era was like. So we will go over the notes on those 4 eras, and we will color in our reference tables. As you can see, the visual colored yellow, green, blue and red to represent those 4 eras. We'll do that tomorrow in class. So here you can just jot a few notes about each of the eras. They kind of introduced it in that little animated video. We'll talk more about them tomorrow, starting with the Precambrian, which notice it took about 85% of total geologic time. So for the far majority of Earth, there was just simple life on the planet. Right, things no more complex than algae or bacteria for 85% of Earth's history. The green color on our reference tables will be the Paleozoic. That was only 8 or 9%. That's where we get the evolution of simple animals, right, progressing from invertebrates to fish to amphibians. And we also see the first land plants and animals. And those are some of the period names that you've been using, like from Cambrian all the way up to the Permian, all part of the Paleozoic. The Mesozoic, right, meaning the middle, right, that's the blue one. It's only about 3 or 4% of geologic history. If you take that blue and squeeze it all the way over onto the left of the reference tables, it takes a small chunk. That is also known as the age of the reptiles, right? Age of the dinosaurs, the Triassic, Jurassic, and Cretaceous periods. We also see the first birds and mammal fossils in the Mesozoic. In the Cenozoic is only about 2 or 3% of geologic history. So we color in our reference tables red, and we'll slide that all over to a tiny, tiny little portion on the left. That's also referred to as the age of mammals, and includes the very end where humans first appear. Human existence is very tiny compared to the whole 4.6 billion years of Earth's history. Overall, humans in the rock record represent 0.04% of geologic history. And then also make sure that on page 9 you remember all the way to the right those diagrams that show where the continents were in the past because of plate tectonics. And then right next to it, the title says Important Geologic Events in New York. So this section has nothing to do with fossils and living things. It all has to do with geologic events like motion of the plates and formation of oceans and formation of igneous intrusions and the formation of mountain ranges, which is called orogeny, the formation of mountains. And you can see a number of orogenies that are referred to on the reference tables. There's little pictures of mountains, and you can actually read which mountain chain was being formed at that time on page 9. There is no place on Earth that has the complete record of 4.6 billion years of Earth. Right? And you may ask, why is that? And that's because there is no spot on Earth that has been underwater creating a record, creating sedimentary rocks for the whole history of Earth. Right? Because things are constantly moving. Places that were underwater get pushed up. We've discussed this with the unconformities and how it's like a yo-yo going underwater and back up and then underwater and back up. So there's change all the time. So in order to get the complete history, scientists have to look in many places. The analogy is like your history book. Right? When they're not finding one book that has it all. So instead they find a chapter or two over in Utah, and they find a chapter in New York, and they find a chapter in Germany, and they find chapters all over the world, and they put these together, they match them up, they correlate them to get the complete 4.6 billion year history of Earth, or as much of it as they can. Part of their ability to do this deals with a principle of uniformitarianism, which basically says the processes that we see working on Earth today, like weathering and erosion and deposition and sedimentation and volcanoes, all of those happened in the past. And the same processes that are occurring today are the same things that happened in the past. So when we look at the rock record, we can figure out what happened in the past by comparing it to these processes today. Right, and the last thing that we will do is we will tomorrow just briefly mention page 3 of the reference tables and how you can see in New York State the different chapters of history. Not all of them represented in New York, but some of them. So that ends Objective 6 video.